Hello everyone. This is the fifth session of the topic data structures. In the last session, you guys learnt about stack, its operations and its applications. In this session, you are going to learn about another data structure, that is queue. Operations on queue, types of queue as well as applications of queue. Queue is a linear data structure where the element is inserted from one end and deleted from another end. Unlike stack, in queue, insertion of element takes place from one end, which is called as rear end, and deletion of element takes place at another end, which is called as a front end. Queue is also called as FIFO data structure, that is first in first out data structure. Why? Because the element which is inserted first is the element which is going to be removed first. Now let us see how to implement a queue. As a queue is a linear data structure, so one dimensional array is used. We require two variables, front and rear, and initial values of these variables is -1, which indicates an empty queue. Another variable max is required, which gives the maximum size of the queue. See the example here. Maximum size of the queue is 6. 5 elements are inserted. Rear is pointing to the last element which is inserted. Front is pointing to the first element which is going to be deleted. Some of the operations that can be performed on a queue are peek, is full, is empty, enqueue, dequeue and display. Peek operation is used to access the element which is present at the front of the queue. Is full operation checks whether the queue is full or not. Is empty operation checks whether the queue is empty or not. Enqueue operation means to insert an element into a queue. See the algorithm. First we need to check queue full condition, that is queue overflow condition. If rear is equal to n-1, that is maximum size -1, then it represents that queue is full. Otherwise there are two possibilities. Either the queue is empty or queue contains some elements. If the queue is empty, that is if front is equal to null, then just front and rear are made to point to the 0th position. After that, item will be inserted, that is queue of rear is equal to item. At the 0th position, the first item will be inserted. Otherwise, just increment the rear pointer. Rear is equal to rear plus 1, and then at that position new item will be inserted. Let us see one example regarding this. See here. First the queue is empty, front and rear are pointing to -1. After that, one by one the elements are inserted until queue is full. In a dequeue operation, an element is deleted from the queue. See the algorithm. Before deleting, we need to check whether the queue is empty or not. If queue is empty, then there are no items to be deleted. How to check that? If front is equal to null, then it indicates that queue underflow, that is queue is empty. Otherwise, the item is deleted first, that is the item to which the front is pointing is deleted. Here again there are two possibilities. If that was the only last item which is deleted, or there are some more items to be deleted further. How to check that? If front and rear are pointing to the same position, that is if front is equal to rear, then it indicates that it was the only last item left to be deleted. At that point, front and rear are again initialized to null or -1, indicating that there are no items left in the queue. Otherwise, simply front is incremented by 1 to point to the next item which is to be deleted. Let us see one example regarding this. See here. The item to which the front is pointing, that is front will be always pointing to the first item to be deleted. That will be deleted first. After that, the second item, and so on. Elements of queue are displayed starting from front up to rear. First we need to check queue empty or queue underflow condition. How to check that? Same. If front is equal to -1, then it indicates queue is empty. Otherwise, loop starts from front. I is equal to front, I less than equals to rear. That is the end condition. I plus plus. One by one elements of the queue are displayed. Some of the types of queue are simple queue, circular queue, double-ended queue, and priority queue. Simple queue is nothing but a normal queue where insertion and deletion takes place at rear and front end respectively. See the diagram here. In a circular queue, the last element is connected to the first element. See here, the last element is connected to the first element, and again we can insert the elements from starting position only if there are some space left to insert the elements. In a double-ended queue, insertion and deletion can take place at both the ends. See here, we can insert from front end as well as we can remove from front end, whereas we can insert from rear end and as well as remove from the rear end. Priority queue is somewhat different from other types of queue. Here, elements are inserted and deleted according to some priority. See here, in this queue, the element with lowest value is given a low priority, element with the highest value is given a high priority. So deletion operation takes place from above, that is top priority element is removed first. So while inserting, if the element is having a lower priority, then it is inserted from below position. Next, we'll see some applications of queue. First one is when a resource is shared among multiple users. See, for example, when a printer is shared among many computers, so all the computers will be giving request to that printer to print their documents. So all the requests will be held up in a queue and they are served in a first come first serve basis. In call center phone systems, when the customer calls to a call center, that customer will be held up until he is provided with the service of that call center. Queues are also used to solve some of the algorithms such as depth first search and breadth first search, etc. And at last, some of the real life applications of queue are in banking system, queue lines in ticket counters, in railway station, bus stand, etc.